Hello there, Mr. Vessel here, and I'd like to take today a look at an AP Stats problem from 2013. It's the first problem on that particular exam, and it has a it's one of those weird exams that had a confidence interval to be constructed and interpreted on the first question. Something I'd like to look at close. It says an environmental group conducted a study to determine whether crows in a certain region were ingesting food containing unhealthy levels of lead. A biologist classified lead levels greater than 6.0 parts per million as unhealthy. The lead levels of a random sample of 23 crows in the region were measured and recorded, and the data are shown in the stem plot below. So, got this display here. We get the stem and leaf plot, and we get a little key so we can see how to read the key. And in this case, what proportion of the crows in the sample had lead levels that are classified by the biologist as unhealthy. And in this case, we just got to read the display. So remember, he said before that 6.0 was unhealthy, so we can read that from the chart here. It looks like there are 4 crows that are above 6.0. So in order to get the correct proportion for this, the proportion of unhealthy is 4 out of 23. Leave it just like that. And the next one is really the nuts and bolts of this question. A lot more to do for the second part here. So it says the mean lead level of 23 crows in the sample was 4.90 parts per million, and the standard deviation was 1.12. Construct and interpret a 95% confidence interval for the mean lead level of crows in the region. So when you see this word construct, construct has a couple of things that are really important to remember. Not only do you have to just calculate it, you also need to name this test. You got to check the conditions for this interval, and then you can calculate the interval before you can finally interpret it. So the word construct has a lot of parts to it that we're going to make sure we do here. So the first thing we're going to do is we're going to make a one sample t interval for a mean. And t intervals, again, they're used when we're creating means, and it's really typically because we don't have this standard deviation of all crows in the population. We use this sample. So t interval is going to be used for the mean here, and we're also going to use the formula. The formula, x bar, is our sample mean here, and we're going to have to find our critical t-score, and we'll use our standard deviation for this sample over the square root of n for our sample size here. But before we can do this, we've got to check our conditions, and there's a couple of them that we have to be able to make sure that we can say are met here. And the conditions in this case, one that's always a condition for any kind of interval or test that you might do is, was it a random sample? Was it SRS? So this was given up in the prompt. It said lead levels of a random sample of 23 crows. So it said random sample of 23 crows. So that part's okay. Got the randomness. The other condition that's important is that we have to be able to assume it's at least approximately normal. So we want to see that sample size being at least 30. So we don't have that here. So our sample size is 23. It's not large. So it doesn't rule out the fact that we can use t or not use t. But what's really important in this one is you need to be able to use the display from above. So since the stem and leaf do not show any major skew or outliers, these two things are important to describe here. Using a t distribution, or using a t distribution, will work. So it's really important to mention that if we can't use this t if there's some massive outliers, we've got maybe a heavy skew to the left or heavy skew to the right. So in this particular case, we do see, go back to this display here, the display is fairly symmetric. It might have a slight skew, but it's not a massive skew, and there definitely aren't any really extreme values, upper or lower ones. So using a t interval here is going to be okay, but these two conditions are really important to describe here, and it's not just writing SRS check. You have to make sure that the grader knows how you know that it's true too. So in this case, the other one, the 23, it's not quite 30. It'd be great if they took a little bit larger sample. We'd have a safer, we wouldn't have to check all this other stuff. But because our sample's not quite large, we definitely need to mention the fact that there's not major skew, there's no outliers here, so a t is going to be okay to use here. And then the other thing that I want to mention with a t interval like this, we need to get the degrees of freedom here. So the degree of freedom, n-1, is going to be 22 in this case. So we'll use 22 degrees of freedom, and that'll help us find this critical t-score here. So the t-score for a 95% interval at 22 degrees of freedom, we'll go to our t-table here and find the 95 down here at the bottom, and just go up to, I see the 22 degrees of freedom, it's 2.074. So that'll be our critical t-score in this case. And everything else has been provided. So we'll go through and we'll calculate our confidence interval now. So the sample mean was 4.90. 2.074. Standard deviation was 1.12. And our square root was 23. Or sorry, our sample size was 23. Alright, so just type this in one step. It's usually the best way to go with these. And oops, forgot to hit the multiplication button. 1.12 over the square root of 23, and this will give us our upper bound. And really quickly, we can get our lower bound. Just change the plus to a minus. So we got our two endpoints here, 4.4. Well, let's use 16 and 5.384. So here is our confidence interval, and then the final piece to this, we have to be able to interpret it. So let's do that. We're 95% confident. And usually you can interpret this really well just by looking back at what the question was originally. So right up here it says the mean lead level of crows in the region. So I want to make sure that I get it back in context and even use units in this case. So we're 95% confident the true mean lead level of crows in this region is between 4.416 ppm and 5.384 parts per million. And that does everything we need it to do. We got to mention the percent confident we are. We got to mention that we just measured a true mean. It's not a sample mean. We use our sample to estimate the true parameter, and it's about lead levels of concentration in parts per million. So all of that has been met, and really that's all there is to this whole task here. So that's the 2013 problem number 1. Really appreciate you checking this out. Please see more videos if you'd like to subscribe. Thank you very much for checking this out.